lesson 5 on this short unit is in regards to adding or operating vectors graphically. So what we have seen up to now is that we have seen vectors, so we're able to describe them in terms of either bearing or positive x-axis or northeast southwest axis. And then now we will see, okay, when we represent a vector, how can we operate graphically? How can we add, subtract, even multiply with a coefficient graphically? How this will look like when we work graphically. And as you notice on Physics 20, and not only, on sciences in general, what you face is, okay, this is how we operate mathematically, and this is how it looks like when we draw them graphically, or this is how the graph look like when we have this relationship. Okay, so this is why we leave it at the end, because we see what is graphic mathematically, so we understand better what is the logic behind that, and then we attach into it, okay, how this will look when we are using graphing, graphically, visually, how that will look like. When we are operating with vectors graphically, there are two ways that we deal with them. The first one is known as the closed polygon method. The closed polygon method is a method that is used widely, graphically, adding vectors, when we have more than two vectors. It's very effective. So on this case, what is happening is that we have a vector A, we have a vector B, and a vector C. And what we are finding is what is A plus B plus C. Now we know how to do this graphically, mathematically, but now graphically is we plot the vectors one after the other. And when we are done with plotting all of them, all the vectors that we are operating with, what do we do is we close the polygon. Ring. And this is the resultant vector. Now you may say, okay, Miss, but what is the magnitude and what is the direction? So everything that you do here on graphical method is you do it based on the scale. So you're saying that vector A is, let's suppose, 200 kilometers. Then what do is you use a scale and say that this line segment represents 200 kilometers. And then the same scale you will use for the other vectors. And the angles will be whatever is the angle. If it is vector C, let's say, because for vector A is straight north, for vector B is straight east or due east. And for vector C, whatever they are giving you, if they are giving you the angle with the east axis, then you will plot that value there, and then you will draw vector C. And if they are giving you the angle with the south axis, then you will take that value of the south axis, of the angle of this with the south axis, and you plot it there. And then using the scale, you will draw what is a vector C. So you will use the same scale for all three vectors to find what is the resultant. And then the way that you find the magnitude of the resultant, you measure the length of the line segment using the scale. You will figure out what is this in kilometers, and then you will measure the angle either with east on this case or with north, whatever you prefer to define the vector. Now, will it be questions that you have to use the scale and plot those vectors? No, but you should be able to know how are you plotting those vectors in order to figure out what is the resultant vector. To go back to the examples that we did before, when we have a horizontal vector horizontal and a vertical component of the resultant, vertical and horizontal, what we are doing when we find the resultant vector on the previous examples is actually we are using the closed polygon method. So we are plotting the vertical and then the horizontal, and then we are closing the polygon by saying that this, what actually is the vertical component plus the horizontal component of the resultant vector. Okay, so let's see now more examples with closed polygon. So let's suppose that we have a vector A that look like this, and then we have a vector B that looks like this, and then we have a vector C that looks like this, and then we have a vector D that looks like this. And what we are doing, actually we are finding a vector R that is A minus B plus C minus 2D. Okay, so what we will do in order to figure out graphically using the closed polygon method, we'll plot those vectors one after the other. Remember what we said when we are subtracting. So this is the same as saying you are adding vector A and you are adding the opposite of vector B. You are adding vector C and you are adding the opposite of 2D. Okay, so we'll pick a space or starting point where we will be able to draw all the vectors so that we are dealing with, and then we will plot A opposite B, C, and opposite 2D. So vector, I will pick this as the starting point. So this is the starting point. And then vector A, I will bring the vector A at the starting point, meaning that I will freeze the vector A and then move it to the starting point of the vector to the starting point of our sum. So vector A will be something like this. Okay, and now the relationship dictates us negative B. If we were plotting B, then we would go something like this. Okay, this will be vector B. But actually, the question or the relationship is dictating us to go negative B. Opposite vector means the same magnitude, opposite direction. So what do? You extend vector B on the other direction, on the opposite direction, and you plot the same magnitude. So let's say this is 3.5 squares, so will be this one here. So this one here will be negative B. Okay, and then the relationship tells us, okay, plot vector C. So vector C as it is. Okay, we will take vector C and then we'll say, okay, at the end of vector negative B, we will plot what is the vector C. So vector C will be, let's draw it something like this. Okay, we will bring vector C here. And then now what do we have? is a vector negative 2D. If we were going with D, then we will go down, okay? Down, what is it? About three squares down, since this is D. Since we want negative D, then we will go on the opposite direction. We will go up, okay? From here will be about here. This is negative 1D, and then negative 1D more will be negative 2D. Okay, so the whole thing here will be negative 2D. This one whole thing here is negative 2D. And then closing the polygon from the starting point to the end point. So we'll draw a vector that starts at the starting point and end at the end point of the resultant. So we'll have a vector that goes like this. This one here will be the resultant vector. Does it make sense? Let's see another question. Let's suppose that we have vector A that looks like this, vector B that is like this, vector C that is like this. And what we are finding is the resultant of 2A minus B minus 2C. Okay, we'll start with a starting point. So the starting point being here. And then we will start 2A. So 1A and 2A is this one here. Multiply the magnitude or plot the vector twice, the same direction. If it was B, you will go straight down, since it is B. Since it is negative B, you will go up in the opposite direction with the same magnitude. And then you have, if it was C, you will 2C, then you will go 1C here and 1C here. So this will be 2C. Since it is negative 2C, you will extend it on the opposite direction. Like this. And this will be negative 2C. And closing the polygon, or drawing a vector that starts at the starting point and end at the end point, will be the resultant vector. The formula, the relationship, this one here, will be given to you. Okay, you don't have to make it up. Will be given to you. Whatever is it, will be given to you. Okay? The second method that we use to graph, to represent how to work with two vectors is that it is known as the parallelogram method. So you have two vectors, vector A and vector B, and what you are doing is you are finding the resultant, vector A plus vector B. What do you do is you start at a point that is the starting point, and everything starts at that point. So the two vectors that you are operating with and the resultant start at this point. Everything starts at this point. So at that point, you bring vector A, which will be given to you, the direction or and the magnitude. And then you plot at the same point, you plot vector B. And now using those two lines, you will construct the parallelogram, and this is why the name parallelogram comes from. You will construct the parallelogram. Keep in mind what parallelogram is a 2D shape that sides are 2 by 2 equal and parallel to each other. So this side where vector A is will be equal to the opposite side and parallel on the same time. And this side where vector B is will be equal and parallel to the opposite side. Now, those two lines will intersect at a point. Then, starting at the starting point, as I said, everything in the parallelogram method start at the starting point. Starting at the starting point, you will draw a diagonal of this parallelogram that will represent the resultant vector. Okay. Now, this method is very good when we are working with two vectors. Now, what we have seen prior when we had a horizontal component and a vertical component, so a horizontal component of the resultant and a vertical component of the resultant, then to use this method, what do you have to do is you have to construct a parallelogram, which in this case is a rectangle. And then from the starting point, you will draw a diagonal, and this will be the resultant vector. Now, I don't prefer to use parallelogram method when I have the resultant, the component of the resultant, because it is an extra step to build the rectangle and then to draw the resultant vector. But the results will be the same. It's pretty much the same. Okay, so now if we have, let's say, vector A as this one here, and vector B as this one here, and what we are finding is actually our A minus B, we will use the same logic. When we are subtracting two vectors, we are adding with the opposite vector. So now, how do we do this in terms of the parallelogram method? So we pick a starting point and we bring the first one, vector A, that looked like this. And now if we were going with vector B, then we will go east. Since we are going with opposite B, then we will go on the opposite direction, okay? So this will be negative B, okay? This will be negative B. Now, using those two lines, A and negative B, what we will do is we will construct a parallelogram. So we'll draw a parallel to A, and we will draw a parallel to B, and this will be the, okay, this is the closed polygon method. Okay, so the closed polygon method will give us this one here, the resultant. And if we are drawing now the parallelogram method, then we will have the same thing. So B, negative B will be here. Will be here. And then we will construct the parallelogram, and the resultant will be starting at the starting point, going across the diagonal. So it doesn't matter which method you are using, either the closed polygon method or the parallelogram method, the resultant is the same for two particular vectors. It doesn't really matter, okay? This is a proof that says that vector A and vector B, when we are using the closed polygon method, will give us the resultant R, and when we are using the parallelogram method, will give us the same resultant R. And I have the tendency to use the closed polygon method for the horizontal and vertical component of the resultant because I omit doing that extra step into the calculations, but you can do whatever you want. Okay, so now the question will be, what if I have more than 2 vectors to add, and the restriction is that I have to add them using the parallelogram method? What you will do is you will draw the resultant of 2, and then on this resultant of 2, using the polygon, you will take that and will draw a new parallelogram with the resultant of the first 2 and the third one, and then you will take that resultant and then you will draw a third parallelogram with the resultant of the 3 and with the fourth one, and so on. So this is why closed polygon method is widely used when we have more than 2 vectors to add, and parallelogram method is widely used when we have 2 vectors to operate with. Parallelogram method is kind of the same difficulty, let's say, with a closed polygon method when we have 2, but when we have more than 2 vectors to operate with, closed polygon method is the way to go. Does this make sense? Let's do 1 or more 2 examples. So let's suppose that we have a vector A that look like this, and then we have a vector B that look like this. And what we are doing is we are finding a resultant of vector 2A minus 2, let's say 1 over 3B, 1 over 3B. Okay, so this is the same as saying we are adding a vector 2A to the opposite 1 over 3B. So when we see this 1 over 3, if B is this one here, then what do? Is we divide it into 3 parts. So this is pretty much divided into 3 parts. And this vector here will be 1 over 3B. And when we are doing the negative 1 over 3B, will be this vector here. So when we draw, when we find the resultant of 2A minus 1 over 3B, using the parallelogram method, what we will do is we'll pick a point as the starting point, and then we'll draw vector A and another one A to make it 2A. Okay, so this is the starting point. At the same starting point, what we will do is we will enter the negative 1 over 3B. So negative 1 over 3B is this one here. Using those 2 sides, so we will construct the parallelogram method, or the parallelogram, sorry. Okay, and then the vector that starts at the starting point and goes along the diagonal will be the resultant vector. This is the resultant vector. And now if you have a third vector, what you will do is you will take this resultant and then you will use it to construct a second parallelogram, and so on and so forth until you are done with all the vectors that you are adding. Is this clear? Okay, let's do together this this practice question here, where we are having A and B and C, and we are just adding A and B and C together. And then what we are doing is we are adding A to negative B and C. Let's do that in both methods so that we can see that using closed polygon when we have 2 more than 2 vectors to operate with is way easier. If we have closed polygons, so closed polygon method, what we will do is we'll start with vector A. So we'll go vector A here. And then we'll at the tip of vector A, we will add vector B. At the tip of vector B, we will add vector C. And the line or the vector that closes the polygon, so start at the starting point and end at the end point, is the resultant vector. This is the resultant vector, A plus B plus C. Okay, and if we are doing this, the exact same question, using the parallelogram method, what we will do is first we'll work with A and B, or A and C. The order in vectors doesn't really matter. So we'll go vector A, and then into the same starting point, we will go with vector B. I will just erase this, draw it here. Vector A, and then here we will have vector B. Using those two lines, so we will draw the parallelogram. So first this one here. As you see, it's not quite this and this. So this will be a resultant vector, just A and B. A and B. And then we'll take this resultant vector and we will add vector C here. And with those two lines, we will construct the parallelogram. Oops, not there. With those two lines, we'll construct the parallelogram. So then, starting at the starting point, everything starts at the starting point with a parallelogram method. We will have vector A plus B plus C. So as you see, the closed polygon method, which is this one here, the parallelogram method, which is this one here. It is way more confusing when we have more than 2 vectors to operate with. And if we have 4, then you will take this resultant and draw it again. So what we are doing pretty much on the parallelogram method is if we are trying to find A plus B plus C, we find a resultant here, let's call it R1, and then we add that to C, and if we have a 4th one, then we find the resultant 2, and we add that to D, and so on and so forth. Does this make sense? So when we are finding this, A minus B plus C, what we will do is we'll do just the closed polygon one, because as I said, when we have more than 2 vectors, using the parallelogram method is very confusing and very mind-blowing. I will just do the closed polygon one. So we'll start vector A, which is a vector that goes like this. So vector A, Vector B is a vector that goes up as well. So we'll do negative B will be something like this. And vector C is a vector that goes further down. So will be a vector that is like this. So then the vector that closes the polygon, starting at the starting point and ending at the end point, will be the resultant vector A minus B plus C. Okay, with this lesson, we finished that is known as the basic unit. So what do you have to know on this unit to do well on the quiz and on the test is to know how to solve any triangle, including the right angle triangle. If not, then you can refer to the lesson that is on this notebook. You should know how to find the horizontal component and the vertical component of any vector. The vector that is described using either bearing or northeast southwest axis or the positive and negative. Usually will be northeast southwest axis. Then you should know how to operate with vectors using components, so building the table of components, and how to operate with vector graphically. If you know all those things, so then you can go to the practice test, which I will open on D12. Okay, do you have any questions?